All right, let's talk live streaming. Have you ever wondered how, when you're watching a massive sports event, it gets from that stadium to your screen, like instantly? Well, today we are breaking down the very first and maybe most critical part of that journey, how that live video gets captured, sent, and prepped for millions of people, all in the blink of an eye. First things first, we've got to be clear. Live streaming is a completely different animal than something like Netflix. See, with Netflix, they get the whole movie file way in advance. They can upload it, process it, take their time. There's zero rush. But with a live broadcast, the game is happening right now. Every single second counts. There is no later. The system has to handle this constant, unending flood of video data, and it has to do it instantly without ever falling behind. Okay, so let's follow a little piece of video on its big adventure. The very first challenge is what I like to call the handoff. It's all about getting that stream from the camera at the event to the big cloud servers, and it has to be flawless. This first step, it's absolutely crucial. Now, to make that handoff actually work, you need a special kind of language, a protocol that everyone agrees on. And for this job, the industry standard is called RTMP, the Real-Time Messaging Protocol. If you've ever streamed on YouTube Live or Twitch, you've used RTMP. Its whole purpose in life is to reliably pack up that live video and ship it from the source to the server. So why is RTMP so reliable? Well, it's because it's built on top of another protocol called TCP. The easiest way to think about TCP is like sending a package with tracking and delivery confirmation. Yeah, it might be a little bit slower, but you are guaranteed that every single piece arrives, and it all arrives in the right order. The alternative, UDP, is more like just tossing a bunch of postcards in the mail. Super fast, sure, but who knows if they'll all get there or in what order. For this first critical step of the journey, you need that guarantee. You just can't afford to lose a single packet of video here. So, great news! Our perfect high-quality video stream has arrived safe and sound at the server. But you know what? Now the real challenge begins. How do you take that one beautiful stream and get it ready for millions of completely different screens all at the same time? And here's the problem in a nutshell. You've got this gorgeous 8K stream coming in, but think about who's watching. One person is kicked back in front of a giant 4K TV with a super fast internet connection. Someone else is on their laptop in a coffee shop with spotty Wi-Fi, and a third person is trying to watch on their phone with just 1 bar of service. You obviously can't send that massive 8K stream to everybody. It just wouldn't work. The solution is this huge, real-time transformation process. The system grabs that one incoming stream and immediately starts making tons of different versions of it. First, it creates all the different resolutions, from that pristine 8K all the way down to a version that'll play smoothly on a phone, like 360p. Then it has to create different formats, which are kind of like different languages that devices speak. Android devices might need one kind, while Apple devices need another. When you add it all up, for just one live game, we could be talking about hundreds of these conversion tasks all happening at once. So how on earth does a system juggle hundreds of really demanding video conversions at the exact same time and without missing a beat? Let's pop the hood and look at the really clever architecture that makes this whole thing possible. Okay, so it all starts with something called a transformation service. You can think of this as the project manager. As that video stream comes in, this manager instantly figures out every single version we're going to need. It then breaks all that work down into individual jobs, like make a 720p version or make an HLS version, and it puts all those jobs onto a central to-do list, which in the tech world is called a message queue. Next up, you have a whole army of worker servers. These are the ones that do all the heavy lifting. They are all just sitting there constantly watching that to-do list. The second a new task pops up, the next available worker snags it and gets to work on the conversion. And the beauty of this system is how it scales. If things get really busy, you don't have to panic. You just add more workers to the army. Now, this is where the system gets really, really efficient. Once a worker finishes converting its video file, it doesn't try to send that huge file all the way back to the manager. I mean, can you imagine the traffic jam that would create? No way. Instead, it takes the finished product and places it in a giant shared digital warehouse. Basically, a massive hard drive in the cloud that everyone can get to. We call this distributed file storage. And finally, the last step. After the worker drops the file in that warehouse, it sends a tiny, simple message back that just says, "Hey, I'm done." That little notification lets the whole system know that a brand new version of the video is ready and waiting for anyone who needs it. It's incredibly simple and efficient. All right, I know that was a lot of moving parts, so let's just take a quick breath and recap that entire journey, from the camera at the stadium all the way to our video being perfectly prepped and ready for broadcast. So there you have it. It's a really elegant system when you see it all together. First, the video is ingested reliably. Then, a manager creates a to-do list. An army of workers processes everything in parallel. And because the manager and the workers are separate, what engineers call a decoupled architecture, the system can scale to handle almost any amount of traffic. It's how they make sure there's a perfect stream ready for every single viewer, no matter what. You know, this quote from our source material just absolutely nails the most important point. It all goes back to that very first step. If the video you send to the server is blurry or glitchy to begin with, there's no amount of fancy processing in the world that can fix it. It's just going to get worse as it goes down the line. It really drives home why that reliable ingestion using RTMP is the non-negotiable foundation for this whole thing. And that leaves us with one last massive question. Okay, we've solved the preparation problem. The video is perfectly converted. It's sitting there in all its different formats in the digital warehouse. But now, how in the world do you actually deliver it to 10 million people all at the exact same second? Well, that is the incredible challenge of distribution, and it is a story for another time. Thanks for watching.